I wanted to show you a couple of examples of cyclic dienes and Diels-Alder reactions. And the first thing we want to do is convert this to a situation where we've got the diene and dienophile sort of looking more like this, so we can draw our arrows and get our product that way. So we're going to do the same thing with this. So it's just a matter of orientation and arrangement. So we'll put the diene over here, facing in the same direction. And then we'll have the dienophile over here. And have the main part of it pointing away from the diene. We'll put C's in at the end of the diene. And then we can be in a position to, and the C's at the end of dienophile. Now we can go ahead and put the arrows in, recognizing, of course, that the carbon here will join to the carbon here, and this carbon will join to this carbon. So I guess if I was to draw it in a 2D fashion, it would look something like this. And given the dienophile, we should always show the stereochemistry about where the dienophile was. That's in accordance with what we've been talking about with preservation of stereochemistry. Alright, so that gives us that, but that would be 2 dimensions, but that's not a decent way to express this. If we want to express it responsibly, we need to do so in a 3D fashion, and the 3D fashion will obey all the bond angles that we know about. So the way it would look in 3D is like this. There's the C's on the diene there. And when we're drawing it in 3D, this is kind of the way I like to do it. Let's try it again. Trying to sort of get this so it looks decent. There we go, that's better. And I'd like to kind of keep these lines as parallel as I can. They're not particularly parallel, but it's good enough for what we want. Now what I'm doing here is drawing what I'm calling the bridge. Now the bridge will always be the whatever was joining the ends of the diene together, and that would be the bridge right here, or if you like right here. And there's a double bond down here. And now we can draw in the bits of the dienophile. And since this is all sp3 hybridized, we can either draw the dienophile pointing down, or we can draw it pointing up as well. I'll draw it pointing down first. Since it is pointing down, then that's going to be called endo, because it's pointing in the same direction as where the diene was, or if you like, where the double bond formed from the diene. If it's pointing in that same direction, that's endo. Now if that's pointing down, it means these methyl groups that were connected on the other side of the dienophile are going to be pointing upwards, and that's what we're seeing here. So that's what the endo looks like. I'll draw you the exo as well. Alright, so we'll go push that up. And the methyl groups will be sticking down. We'll still have a double bond over here as well. and this one would be exo. Alright, so that's the endo and exo forms for that one. Let's take a look at the other one now. Alright, again, we're going to do it the same way as we did the previous one. So I'll set this up in the fashion I've got over here. And again, I will draw it so that the main part of the dienophile is pointing away from diene. And here's the ends of the diene, and here's the dienophile right here. So I'll draw in my arrows. And I will go ahead and show you what the 2D would look like. And again, I'll show stereochemistry on the C's from the dienophile. And this, again, this would be, I guess, exo that I'm drawing here. Of course, you could draw endo as well, but this is what the 2D diagram would look like. But we're not going to draw it like that. I'm just showing you that so you can see where the carbons are. But now let's look at what the 3D diagram looks like. We'll draw that in the same way as we do the other one. Now look at this. This will be the bridge right here between the C's from the diene. That's what we expect the bridge to look like. So that'll be the bridge there. So now we can have the double bond here. And since I've got stuff connected to the double bond, that's actually going to be flat because the double bond is going to have a flat geometry. So this would be pretty much in line with what we've got here. It would not be sticking up or down. That's because of the double bond. Now this can either be drawn with the ring pointing downwards. That would be endo. And the NO2 sticking upwards. Alright, so this will be endo. And let's take a look now at the other one, the exo. The exo would look like this. And there's our bridge there. We'll have the cyclobutyl ring at the back, and it's pretty much in line with these because the double bond is flat. And I'll have the other one with the ring pointing upwards. And the NO2 groups sticking downwards. And this would be exo right here. Alright, so just repeating where the C's are. You've got the C's here, these are the ends of the diene. C's here, that's the dienophile. Here and here for the diene, here and here for the dienophile.